All right, welcome to the 1.3 notes here. We're going to be going over the midpoint and distance formulas, a little bit of vocab initially here, talking about what exactly is a midpoint, what exactly is a segment bisector before we get to those formulas. Okay, a little bit of algebra as well involving those concepts. So let's just jump right in, get to it here. So the first thing, let's get that vocab out of the way so we can kind of have an idea of what we're talking about here. First thing, midpoint. Okay, the definition is it's a point. It's kind of all in the name there as far as hopefully understanding what's going on. We got a midpoint. It's a point in the middle. It divides a segment into two congruent segments. All right, so it's right in the middle. Picture-wise, it's a good illustration here. We've got segment AB, okay, the longer segment. Point M has got to be the midpoint. Point M is the midpoint because it's dividing segment AB into segments AM and segments MB, but both are marked as congruent, which is essentially that definition. Okay, so we would know lengthwise that the length of AM is equal to MB based on them being congruent. Okay, the one that we'll add, so add that to our notebook as far as a definition, the picture that goes with it. Next thing we'll look at here is just more of a general term to bisect something, or so as like a verb, to divide. Let's just say it like this: to divide, and let's keep it kind of broad here, to divide something or anything, let's just say something, into two congruent parts. Okay, so you're thinking, well, what the heck? This is the same thing. Midpoint is very specific. It divides a segment, right in the middle. Okay, it's a point that divides a segment. Just in general, to bisect something is to divide anything. We could, in theory, bisect an apple if we were to, accurately measure it and cut it into two congruent parts, kind of right down the middle. All right, so that's what bisect is as a verb. To bisect something is to divide it kind of in half. So for us, where that kind of leads to then is a segment bisector, which is more broad, more general than a midpoint. It's anything really that we know of geometrically speaking, a point, a ray, a line, a segment, or even a plane that intersects a segment at its midpoint. And you're kind of thinking, well, what the heck? I thought, is that what we just talked about, a midpoint and a segment bisector? A midpoint does fall into this category. It's a point that intersects at a segment's midpoint. So yes, a midpoint is a segment bisector, but there could be many things beyond a midpoint. There is only one midpoint of a line. You could have really an infinite amount of segment bisectors. So let's take a look here. I think it's a pretty good illustration. Very similar picture, right? We've got segment AB. M is the midpoint again. I know that's the midpoint because of these tick marks right here. But now I've got a line that's also passing through that midpoint, line CD or line DC. It could be classified as a segment bisector because it passes through the midpoint. All right, we could add, like I said, infinite. We could sit here all day and say, all right, whoops, kind of missed my midpoint there. But I've got another segment, maybe XY, that passes through that midpoint, if I was able to draw accurately through that midpoint. So we could say segment XY now is a segment bisector because it passes through that midpoint. I could add, let's just add one more here, like ray. Let's see if we can hit it that time. Ray, even if I didn't add another point, ray, let's see, what letter have we used here? Q. Ray QD also falls into that description of a ray that intersects a segment at its midpoint. Okay, so it's a little bit more broad than a midpoint. A midpoint can only be a point in the middle. These all pass through a midpoint of a segment, okay? So a lot of stuff with cutting things in half today, bisecting, midpoint. That's kind of the focus of the lesson. So let's take a look at some algebraic, hopefully relatively simple introductions here to these concepts. So I've got a figure. It's a real short question. It just says find S, or direction. Find RS. Remember that's a loaded abbreviation there, though. It's asking us to find the length of segment RS, which is fine. We can do that. So look at my picture here. I see RS is referring to this whole piece right here. That's kind of what's in question. And really the only part that's missing, if we know that from R to T is 21.7 units, And I'm indicated, or the markings show us that segment RT is congruent to segment TS. Well, that also means that segment TS has to have a length of 21.7. All right, so not overly deep as far as work shown, but it's applying the concept. T is the midpoint of this section. So I in the end, it's going to take us adding up these two numbers here and saying that the length of RS, right? We're going to write our answers, not just throwing random numbers around. The length of segment RS, let's see, 43.4, I think sounds about right. And because there's no units in the problem, I'm okay with us leaving our answer just like that. All right, I've essentially just 21.7 times 2. All right. All right, let's take a look at the next one. All right, so here we've got a little bit more verbiage going on, but let's see what we got. So it's telling us point C is the midpoint of segment BD. So C is in the middle. And I think it's almost a kind of a redundant. They've marked it too as being the midpoint. So I see these tick marks here and here, which also indicates midpoint. Great, that's awesome. The question, kind of the direction that's asking us to do, we could write that the same way as the last one. Actually, I'd prefer to write it that way when it says find BC. These and these are saying the same thing. I'm just rewriting the question right now, but remember, it could say find BC with nothing above it, and that should hopefully mean something to us as far as, all right, find the length of segment BC. All right, how are we going to go about this? Well, we said earlier that because C is a midpoint, it's right in the middle. I've got my tick marks indicating BC and CD are congruent segments. That means they got to have the same length. That this length right here from B to C is exactly the same length as the length from C to D. So as far as a setup, an algebra setup here, we're talking this length of BC. Well, let's see. Let's clear that for a second. Let's say in words or using abbreviations that BC has to be equal to CD, right? That has to be true. Those lengths have to be equal. And if we do a true substitution now, I'm going to replace BC with 3x minus 2, and then I'll replace CD with our 2x plus 3. And we're left with, in this case, hopefully not too difficult algebra equation. So let's get our constant terms together. We've got some options as far as how we want to solve this here. I guess I'm choosing to get the constant, the number terms together. 3x is equal to 2x plus 5. We'll finish this one. Actually, no division needed. We'll subtract a 2x from both sides, which will leave us with x equal to 5. Not quite done, but I'm feeling pretty good about that. Let's take a look. The last part, or assess, did we answer the question? No, not quite. It was asking us to find the length of segment BC. All right, we can do that. I just got to make sure now that this x, where's BC? Right here. Gets plugged in right there. So to find the actual length of BC, we're going to take our 3 times our x that we just found to be 5 and subtract 2. So 3 times 5 is 15. Minus 2 is 13. And I think we're okay. A quick check to see if did I do this right? Am I sure this is the right answer? I could also take, I know we've answered the question and we're feeling pretty good about it. But if I take this x and plug it in right here, based on what we said earlier, that BC and CD should be the same number, should be equal values. It hopefully doesn't take too much to take this 5, plug it in, and just do even a quick mental check. 2 times 5 is 10. 10 plus 3 is 13. It checks out. Those are the same value. All right, I didn't have to write anything down, but I was able to just kind of verify, hey, I know my answer's right. If it asked me for the whole segment length from B to D, and again, I know it didn't ask us that, but we could answer that question, 13 times 2 or 13 plus 13, 26. All right, so there's the door is open for obviously other types of questions for a problem like this, okay? So that's a little bit of the algebra based on some of that vocab as far as midpoint, bisect, segment, bisector. All right. So the next thing we'll look at here is those formulas, right? So I think hopefully we can find segment lengths using midpoints and bisectors, a little bit of algebra based. Really the last part of the lesson is to let's get to know or reacquaint ourselves or familiarize with these formulas and how do we use them. All right, so this one's kind of a complicated picture. There's a lot going on here. We're essentially getting on the coordinate plane. So hopefully this is something that looks familiar from algebra class. We've got an x and a y axis. Now, if I look on here, just be careful. Let's sift through it here. I've got 2 points, and I'm going to kind of highlight some of this stuff here. We've got point A down here. We've got point B sitting up here. And then I've got this segment AB that connects those 2 endpoints. Now, don't let all these X's and Y's and 1s and 2s throw you here for a loop. All right, it's trying to represent generic coordinates. All right, what does that mean? It means that this point A, whatever it is, has an X coordinate and it has a Y coordinate, right? So whatever those, eventually those will turn into numbers. So the point A has some X and Y coordinate, and B has the same thing going on, different X and Y coordinates. So that's what that means. We've called A point 1, so we've called it X1, Y1. Point B has its own set of coordinates. We're calling that X2 and Y2. Okay? And I know you can read here what's going on. But basically, if we're on a coordinate plane and we want to say, all right, I've got this segment here, segment AB, and we're interested in finding its midpoint right here, point M, we're going to call it point M. What are those coordinates of M? I don't know. Here's our formula for it. All right. It looks kind of complicated with all those X's and 1s, but it's essentially saying when I say X1 plus X2, it's saying take that one endpoint's X coordinate, add it to the other other endpoint's X coordinate, add them up, and divide by 2, which is a fancy way of saying find the average. Average those 2 numbers, average your X coordinates. And then we'll do the same thing with the Y because, a little bit of the Y, our midpoint's in the middle. So our coordinates should be in between our X's and it should be in between our Y's. Okay, so that's our formula. Let's practice it here a little bit. Let's see what it looks like. A couple examples of different things that could be going on. So here's a very straightforward, no picture, which sometimes are making it harder. These are ones that I think we can, most of the time my reaction is to make a picture. I think these are ones because it's a little bit more formula driven where we can get by with just kind of using the points as long as we can interpret what's going on. So the endpoints of segment PR are right here, P and R. It gives us those coordinates. Like I said, they're numbers. That's the X coordinate. That's the Y coordinate. And then R has its own separate set of X and Y coordinate. What it's asking for is find the coordinates of that midpoint. So a straightforward application of that formula we just talked about. I'm going to write the formula out just so we can see it. All right. So I kind of set it up like this, where we're looking for the coordinate of that X midpoint, and we're looking for the coordinate of that Y the Y coordinate of the midpoint. All right. And that formula then said, all right, take your X, your first endpoint X, your second endpoint X coordinate, add them up and divide by 2. And if I do the same thing for my Y coordinates of the first point, of the second endpoint, we divide that by 2, we should be equal. The numbers that we come up with are going to be the coordinates of the midpoint. All right, let's do it. I think to make it even simpler, as far as, plugging numbers in, just pick a point. Let's call this point 1. Let's call this point 2. All right, and then this can be X1, right? That's the X coordinate. This can be Y1 because it's the first point listed. This can be X2 because it's the X coordinate, and then my Y2 will be that 3 there. Because if I can do that, now I'm essentially looking at kind of a plug and chug situation where I can plug these numbers into the formula, they go where they go, and I'll evaluate it. So I'm going to try to squeeze it in. I know we got another example coming up here, so I don't want to go too far down. So let's see here. Let's work with the X's. X1. I'm going to replace this X1 right here with -2, and I'm going to replace the X2 with our 4 divided by 2. Can I squeeze this in here? Let's see. Maybe we can do it like this. Let's just erase this and start over. Just a little more room. -2 plus 4. Okay, so I'm working with my X coordinates. Let's switch colors here, work with our Y's. Let's go 5 plus 3. Those are my Y coordinates. Divided by 2. We're averaging them. -2 plus 4 is 2, so I'm working straight down here. Let's go back. to our brown color, our beautiful brown color here. Negative 2 plus 4 is 2, so I end up with 2 over 2. And then if I switch back to green, 5 plus 3 is 8, and we'll divide that by 2. And then just simplify it. All right, so the last part is 2 divided by 2, which is 1. 8 divided by 2, which is 4. So when I go to write here's my answer right here. Star it, we're good. The only thing I'll ask you to do, it was asking to find the coordinates of point M. So just the way that these are written, let's write our answer with M, has the coordinates. What did we come up with? 1, 4. So kind of a clustered example here, or cluttered, I guess I should say. There's a lot going on there, but hopefully you're following me there. That's the process for finding the coordinates of a midpoint. All right. Right along with this formula, there's kind of an alternative type of question here that we could ask. Let's take a look at one. So it looks really similar, but notice it's telling us, hey, we know the coordinates of the midpoint is the point 3, 4. The other one endpoint is 1, 6. We're actually being asked to find the coordinates of the other endpoint. So I can't just, like the last example, plug these numbers, 3 plus 1, divide by 2, 4 plus 6, divide by 2, because that's not going to tell me an endpoint. That's the formula for finding a midpoint. Okay? Or in other words, here was the previous example. We knew the endpoint. We knew x and y, x1 and y1. We knew it. We knew the other endpoint, x2 and y2. This was the previous example, and we were able to figure out, hey, what are these 2 points in the middle there? What's the coordinates of that midpoint? How this one differs is now we still know one of the endpoints. So x1 and y1 we still know. We know the midpoint. So xm we know, ym we know. What's in question is, what are the coordinates of this point out here? All right, so it's a different setup. We need to take a different approach. All right, or slightly different approach. Now we have to throw everything out the window, but we just need to kind of think about it a little bit differently. So let's stick with this here. All right, these are kind of in question. We're looking for x2. Whoops, I meant to switch colors there. x2 and y2. That's kind of what we're looking for, right? What do we know? We know one of the endpoints right here. 1, 6 is, I'm going to replace this with 1, 6. That's one of my endpoints. I know my picture's not super accurate. It's kind of just a placeholder though for us. And I'm not saying you have to even make a picture. So I know one of my endpoints is 1, 6. I know the coordinates of my midpoint right here, M, is, let's replace that with 3, and then this 4 right here. That's my coordinate of my midpoint. And we're looking for x2 and y2, right? Some other endpoint, C, we're calling it, those coordinates. All right, let's take a look. I'm going to try to keep it similar to what we did in the last one. So I'll do the work over here. What would we do if this was a midpoint formula one? We would say take x1, add it to x2, which we're looking for, divide by 2, and that should give us our midpoint, x coordinate, which I'm going to hopefully squeeze it in here and call that 3, because we know what it is. It's this 3. That's we're almost starting with the answer. All right, let's do the same thing for our y's. All right, I would take my x1, which is 6, add it to my x2, or I'm sorry, my y2, my y1, which is 6, add it to my y2, which we don't know, divide that by 2, and when that's all said and done, we know the outcome should be 4. All right, so we're kind of reverse engineering our midpoint formula a little bit, okay? All right, so how are we going to get from right here to figure out what this is to right here? Like I said, let's take this back, this reverse engineering approach. At some point, the last thing we did on our previous example was, the last step to get our answer was divide by 2, and then that gave us our answer here. So for us, the step previous to getting this 3 and 4 was to, hey, divide by 2, and we would get what we're getting for 3 and 4 here. So I'm kind of asking myself, what divided by 2 is going to give me 3? And hopefully that's not a terrible question to answer. And same thing, what divided by 2 is going to give me 4 is 8. All right, so I'm kind of working bottom to top here. And if we can squeeze it in, I think I got room here to figure out. Now, the last step basically is, all right, 1 plus something got us to this 6. And then we'll do the same thing over here and say 6 plus something got us to that 8. And hopefully, again, that's something that is, okay, I can do that. There's a little bit of, if it didn't quite jump out at you, you could set up actual equations. 6 plus y2 equals 8, and you solve, subtract a 6 from both sides. I'm not saying you necessarily have to do that, because I think a lot of us can look at this and say, hey, 6 plus what is 8? Well, that must have been 6 plus 2, right? Got us to that 8. Over here, 1 plus what got us to that 6? That must have been 5. So it's a little less formal than using the formula, plugging numbers into a formula. There are other ways to kind of get there. I think a lot of people might be able to look at this and say, all right, I went from 1 to 3. That means this number we went up 2, right? From 1, we went plus 1, plus 2, and I got to 3. So the other x coordinate must be 2 more this way, 5. Hey, look at that. We came up with a 5. So that's even less formal. Some people might say, hey, how did you get from 6 to 4? I went from 6. I went down 2, so to get to the next endpoint, I must have to go down another 2 to get to 2. All right, so I'm not overly, I want to see what you're thinking. Show me what your work is here. I'll clear some space. Let's write our final answer. Our other endpoint, I believe we were calling it C, has the coordinates, what did we come up with? 5, 2. So as long as you're showing me what you're thinking or how your process was, maybe you counted the way we talked about here, you reverse engineered a formula. There's even a more algebraic approach where we set up an equation and solve it. So there we go. A second kind of type of question that might come along with an endpoint, or I'm sorry, with a midpoint type of formula. All right. Let's take a look. I think that's pretty good as far as using that midpoint formula or using that concept of midpoint on a coordinate plane. The last one we got to look at is using this distance formula on a coordinate plane. Oh, maybe we can get there. There we go. So we're looking at similar concept. We're still on the x and y axis. All right. And very similar setup. Like we could almost get by with the same picture. I've still got point A. I've still got point B. It's still got an x1 and y1. Still got an x2 and y2 that represent those endpoints. So now instead of calculating the midpoint, which would be here, which we could do, I want to know exactly how long, what is the distance from A to B? How long is that segment? All right, so for us, the distance, we got to fill this in here, the distance between point A and B, which we could write as AB with nothing above it, right? AB equals, the length of AB equals, this one involves, it's a big square root. It's actually a kind of a modified Pythagorean theorem, or it is. I know we haven't talked about that yet, but involving a right triangle. I'm not going to pretend like you maybe haven't heard of that. It's kind of a modified Pythagorean theorem problem. So here it is. The length of any segment is taking its x-coordinate, the difference in its x-coordinates, x2 minus x1, squaring it, adding that to the difference in your y-coordinates, so y2 minus y1, and squaring it. This is all stuck under this big square root. A lot of operations. We've got subtraction. We've got exponents. We've got addition. We've got a square root at the end. Okay, so kind of a lot to keep track of, but I think a very manageable formula. So we'll need to add that to our notes. We don't have to memorize the formula. Same thing with the midpoint. We don't have to memorize them. I will provide them to you on a quiz, but for homework purposes, you'll want to have these added to your notes. One question I got when simplifying, doesn't the square root just cancel out these squares? Why do we even have this? Can't we just get rid of this and these two squares and say, hey, let's just do x2 minus x1? Unfortunately, it doesn't work that way. This plus kind of makes things a little muddier, and we're not able to just square root to get rid of it. If it was just a single square and a square root, we could do that. But because of this plus here, it makes things a little bit tougher. All right. So anyways, let's take a look, just a straight up application of it here using that distance formula. All right. So approximate the length of segment RT. All right. One thing also sometimes I see, we're not able to just count and say, oh, that's 1, 2, 3, 4, 5, 6, 7 units. Wow, that was easy, Mr. Crow. I'm not using that formula. Again, unfortunately, it doesn't work that way because these aren't all the same length, right? This one might be a little bit shorter than this one, and they're kind of getting longer as we get down there. So I can't do that. You could if it was horizontal. Like if RT was right here, I could go 1, 2, 3, 4, 5, 6 and say, yep. So vertical or horizontal, totally. Let's count. Let's make life easy. But unfortunately, we've got a slope to it here. We're not able to do that. It's not going to be a very good, very accurate approximation. Okay. I think just like the last formula, this becomes, I hesitate to use easy, but easier if I just make it cut and dry. Let's call this 0.1 right here. T is 0.1, and then 0.2 can be over here. So that just means that's the second x coordinate. That's the second y coordinate that we're working with. And then I give everything a place to go in the formula. So as long as I have the formula, which I already told us, I'm just going to use D here to represent like a generic distance or a length. And I'm going to recopy the formula just so you can kind of see x2 minus x1 squared plus parentheses y2 minus y1 squared. As long as I have accurately assigned an x1, a y1, an x2, a y2 to a coordinate, it becomes that same type of just let's get the numbers where they go. All right, so the length of RT, now we'll kind of set up our answer here. The length of RT is equal to, let's see, I'm calling x2 3. So 3 minus x1, which we're calling -4. Be careful there, 3 minus -4. Hopefully we know what's going to happen there. Don't forget our squared. Same thing with our y's. Let's go 3. Oh, I'm sorry. I almost made a mistake there. y2, which is 2. And then our y1 minus 3. We'll square that. All right, so have a step. Again, don't just write an answer down. I know some of it. We're going to use our calculator at some point here because of the square root. But be careful, that you're not going there too early and just saying, all right, I know the answer. I'm going to plug this all in my calculator and write down one answer. I want to see what you're thinking as far as your process a little bit, okay? So let's simplify these. I still haven't touched my calculator yet. I'm leaving the big square root till the very end. But I can do 3 minus -4 without a calculator. That's 7. That's positive 7, right? A minus ends up just turning into a big plus. So 3 plus 4 is 7. And then I'll square it. And then 2 minus 3, again, I can do that without a calculator. 2 minus 3 is -1, which we'll have to square. So far, so good. Hopefully no operation has been too crazy. I'm going to go step by step and show it. Make sure I get this right. Square root of 7. Again, no calculator needed, 49. Be careful here with this -1. If we're kind of just blindly plugging numbers into our calculators, a lot of calculators, if you just type -1 to the second power, my calculator, I have a calculator that says -1. And that's incorrect. My calculator is saying, hey, I want to square the 1 and make it negative afterwards. But we should all know what is -1. If I type it in like this, I'd actually get the correct answer. -1 times -1, we all know that negative times a negative is positive. So we got to be careful as far as just blindly trusting those calculators. I look at this, especially using the parentheses, and say, hey, -1 times -1 is +1. And you're thinking, oh, Mr. Crow, you're making a big deal out of nothing there. I see that a lot. I see a lot of people ending up with negative numbers. Anytime we square a number, we should get a positive answer. Okay? And it makes a difference. Instead of having 49 plus 1, some of us might have had 49 minus 1, and then we end up square rooting the wrong number. So for us, our final kind of step, I can do this again. 49 plus 1 is 50 without a calculator. But instead of 50, some of us might have had 48. The last thing, finally, I'm going to touch my calculator. I'm going to go to it. I know you can't see it, but I'm typing in the square root of 50. All right. I didn't specify, but I said approximate the length here. My calculator is 7.071. So if I round that to the nearest tenth, I'd say about 7.1 units for the length of RT here. So RT equals the square root of 50, which is about 7.1. Totally fine with that. I'll be very specific on a quiz test as to where I'd like you to round. So hopefully that's not an issue with rounding. All right, so that's just a straightforward example. That's about all I would ask you to do for right now with that distance formula, is just be accurately able to use it. Okay, get numbers where they go and simplifying correctly. All right. So I think we can check off all our big ideas, our goals for the lesson. We were able to, that's all the algebra stuff, find the segment lengths, using midpoint concepts and segment bisector concepts. And then we've looked at a couple different ways using that midpoint formula, and then really one application of a distance formula. So there's your 1.3 notes. I will see you in future lessons.